Hey guys, welcome to example 6 from 4.2. This is our last example in section 4.2. So let's start with, I'm going to show you how to do example 6 two different ways. So with that said, I'm going to draw a line in the middle of my notes. Hopefully that will give me enough space to show you same exact question, just two different methods, okay? Okay, so we'll do both of them side by side so you can see the difference between the two. So method number 1 is okay, so let's do the question. Example 6, part A. With what velocity will you hit the water if you step off a 10 meters diving platform? Remember, acceleration due to gravity is 9.8 meters per second. No, you may not round it to 10 meters per second square. I'm sorry, second square. So over here, we will have an assumption. We will assume your water position is going to be at 0, and we will assume diving board or diving platform is going to be at a position of 10 meters above the water. That makes sense. You're diving downward, so the diving board will be above you. Now, over here, you will assume the other way around. You will assume that the diving board will be at 0, and your water position will be at 10. Don't worry, both answers will come out to be the same. You just have to be mindful of a certain thing. Okay. Now, over here on the left side, you were given an acceleration of 9.8 meters per second square. That was stated in the question. But here's why the left side is important. Since you're diving downward, since you are diving, that means you're going down, okay? You have to manually understand that you have to change the given acceleration to a negative 9.8 meters per second square before you can use it. Okay. Now on the right side, because we're making the water higher than the diving board, we are setting the problem up to be a positive acceleration. Now you're going to end up with the same answer, except that when you are interpreting it, you just have to use the word diving or going downward or something similar to that effect. So we'll do both ways. Okay. On the right side, we are using everything as positive. So I'm going to do a star here. We want acceleration and velocity of the dive to be positive. All right. So let's start with the left. So we have velocity is going to be the antiderivative of acceleration. So negative 9.8 times t plus some constant. We have to find that constant. Now to find the constant, you have to be mindful. We will use the time at 0. You have to come up with a point that you know. So t equal to 0. That means velocity must also be 0 at t equals 0, because at the beginning of time you haven't done anything yet, you haven't gone anywhere, so your velocity has to be 0. Using that point, that will help us solve for c. So velocity 0 equals negative 9.8, t is 0 plus c. Well, this means c comes out to be 0, which is awesome because it makes it easy for us. So our first equation is velocity equals to negative 9.8 t. We'll highlight that for that piece. Now let's go over here to the right and do something similar. Again, we are now using the given acceleration as a positive measurement, so 9.8 meters squared. So acceleration is going to be 9.8 meters per second squared. Similarly, we want to find velocity, which is taking the antiderivative of that. So it's going to be 9.8 t plus c. And again, we are going to use at the beginning of time when t equals to 0, your velocity, it's also 0 because you haven't gone anywhere. That will allow us to solve for your constant c. As you can see, this is the same thing, so we get both answers the same except one is positive and one is negative. It will change slightly in a little bit. Now it says, at what velocity will you hit the water if you step off of 10 meters diving platform? What I'm going to do next is now I'm going to find the position. So S of t. So go backwards one more time. Okay. So S of t equals, now we have to go backwards. So we're going to add 1 in the exponent. So now t becomes a 2. Then, okay, I'm going to negative 9.8 is the number we currently have. Because this is a 2, we're going to divide it by 2 or multiply by a half. And don't forget to give us a c. And then we are going to simplify. This is negative 9.8 divided by 2, so that's a negative 4.9 t squared plus c. Yes, we do have to solve for c still. And similarly, we're going to start at the beginning of time when t equals to 0. When t equals to 0, remember, we have made it so that your diving board is 10 meters above the water. So what that means is when t equals to 0, your position is 10. So we have to plug it in and solve for c. So this is 10 equals negative 4.9 times 0 squared plus c. So c comes out to be 10. So your position is negative 4.9 t squared plus 10. We'll hold on to that and we'll go to the right and solve it similarly to the right side. So on the right side, again, we're going to go backwards one more time and do the same thing, do the same kind of math. And as you know already, we're going to get 4.9 t squared plus c. Now, similarly, we're going to use t equals to 0. At t equals to 0, we made it on this side that your diving board position is 0. So your S of t is 0. So when we plug it in, it's going to be 0 equals 4.9 t squared. Oops, t is 0, so plug in 0. So 0 squared plus c. So over here, c is still coming out to be 0. So over here, as you can see, your position is slightly different from the other side. Okay. All right. Now, so be mindful of that. Remember, the question wants us to find the velocity when you touch the water, the velocity on impact. That means when you hit the water. But to find the velocity when you hit the water or on impact, you need to know the time of when you hit the water. So from the position, we are going to solve for time. So we have positions on both sides. What we want to do is on the left side, S of t equals negative 4.9 t squared plus 10. Remember, your water on this left side is going to be at 0. So we're going to set it equal to 0. So 0 equals negative 4.9 t squared plus 10. Move 10 to both sides. So it's going to be a negative 10 equals negative 4.9 t squared. Divide both sides by negative 4.9. Move it up here because I don't have any more space. That's going to give us a positive 10 over a positive 4.9 equals t squared. I'm going to get rid of my decimals. So now I have 100 over 49 equals t squared. That means t is going to come out to plus or minus 10 over 7. Well, time can't be negative, so I can only take a positive 10 over 7. That is the time on impact. That's the time when you hit the water. I'm not really looking forward. That's not my final destination. I'm looking for the velocity when I hit the water, but that is the time on impact. So what we want to do here is go back to velocity, which is right here. We plug in 10 over 7. So negative 9.8 times 10 over 7. This is going to give us a negative 98 over 7. Divide that, we will get a negative 14. So this is negative 14 meters per second. We will write a complete sentence in a little bit, but let's go to the right side to see what's happening if we use the right side equation. Now, similarly, we're going to find the time when you hit water, the time of impact. Well, water on the right side, remember we have decided that it is at positive 10. So we will take the right side. Water equals 10. So we are going to set equals to 10. We're going to solve for t again. As you can see, it's exactly the same, except on this side it's now positive. We know it's now going to be a positive 10 over 7 for the time of impact, the time that you hit the water. We will plug that back in the velocity because we are looking for velocity of impact. So v of 10 over 7 equals 9.8 times 10 over 7, and that will reduce us down to positive 14 meters per second. Now, on the right side, we have decided to keep everything positive. So on the left, we've decided to keep things normal, right? The water is below the diving board. So when you write your answer, it doesn't really matter. When you write your answer, you would use the word in diving down or falling or whatever it is that you want to use to indicate that this is a negative velocity. So the velocity when you hit water is negative 14 meters per second if you're using negative. Now you can also say the velocity from diving downward when you hit water is 14 meters per second. So notice how you're not using the negative sign, but the word diving downward will take into consideration of the negative. So either one would be just fine. Now last part of 4.2. With what velocity will you hit the water if you dive off the platform with an upward velocity of 2 meters per second? Now this is slightly different. This is kind of like you're on the platform, you're jumping up a little bit and then going downward. So this is slightly different. So what's happening here is you are given a velocity 2 meters per second at t equals to 0. Okay, now but on the right side, we are slightly different here. On the right side, we made everything its opposite. So since we made downward velocity positive, then that means upward, that means upward velocity is now negative. Is negative 2 meters per second. Okay, so on the right side, v of t equals negative 9.8 from earlier, and again we still have to solve for our constant. At t equals to 0, we have a velocity of 2. So we plug it in. 2 equals negative 9.8 times 0 plus c. As you can see, this c comes out to be 2. So our velocity is negative 9.8 t plus 2. We'll hold on to that. We'll go to the right and do the same exact thing. Earlier, we had a positive velocity of 9.8 t. We want to find c at t equals to 0. Over here, our velocity is now a -2. So -2 equals 9.8 times t plus, sorry, we need to plug in 0 for t, times 0 plus c. So c comes out to be a -2. So on the right side, velocity is 9.8 t minus 2. We'll do the same thing. Okay, now let's go and move on to position. S of t equals, and earlier, from our math earlier, I'm going to go straight to -4.9 t squared plus now 2t, we're going backwards, plus c. We're looking for the constant of our position. Now at time equals to 0, on this side, I think we made our diving board at 10. So we are going to have position at 10. So 10 equals -4.9 times 0 squared plus 2 times 0 plus c. C comes out to be 10. So the position equation is -4.9 t squared plus 2t plus 10. We will hold on to this position. We would definitely need to solve for the time in a little bit, but go on the right side and do the same thing. Position is going to be 4.9 t squared minus 2t plus some constant. Remember, over here, we made the diving board at 0. So at time equals to 0, our position of the diving board is 0. So 0 equals 4.9 times 0 squared minus 2 times 0 plus c. This tells me everything is 0. So our position on this right side is 4.9 t squared minus 2t plus 0, but why would you want to write that? Okay, so we have two position equations depending on what we assume at the beginning. So now we need to find the time of impact. On the left side, I'm going to use our, doesn't look like factoring, it's that friendly, so I'm going to use the quadratic formula. So -b plus or minus square root b squared minus 4ac all over 2a. So -2 plus or minus square root b squared, so that's going to be 2 squared minus 4 times a, which is -4.9, times c, which is 10, all over 2 times -4.9. Now let's try to simplify this all out. This is -2 plus or minus 10 rad 2 all over -9.8. So now plug it in your calculator. One of it's going to give you a negative time, which we can't keep, and then one of it's going to come out to be 1.65, which we will keep. So for this side, now velocity on impact. Let's go back to velocity of impact. So here, V of 1.65 is, plug it all in, you're going to get 14.4 meters per second. That's our velocity on impact. On the right side, we would do something similar, except on the right side, remember our diving board is 10. So, oh, it was a diving board 10? Let me go back and look. No, we said the diving board was 0 and water was 10. So water is where we're in, where we touch water, which is 10 equals 4.9 t squared minus 2t. And again, similarly, we will try to solve for t, which is the time of impact. So move the 10 over. So 4.9 t squared minus 2t minus 10. Again, use your quadratic formula. So t equals -b, which is 2 plus or minus square root b squared, which is going to be -2 quantity squared. So 4 minus 2 times a, which is 4.9, times c, which is -10, all over 2 times 4.9. All the numbers are exactly the same. For this one, I'm going to simplify that down to 1 plus 5 rad 2 all over 4.9. After I simplify, as you can see, I got rid of the negative because it's not plus or minus anymore. I'm only keeping the positive time. So once I plug it into our velocity of impact, V of 1 plus 5 rad 2 all over 4.9, this is going to give us a positive 14.14 meters per second. Can you do me a favor? I forgot. Can you do me a favor and go and put a negative right here? I forgot the negative sign. Because when you plug in negative 9.8 times 1.65, it's going to turn out to be a negative answer. So, similarly to either method, one will give you a negative sign right away, indicating that you're going to go downward, and one is going to give you a positive answer because we're making all of it positive. So when you write your final answer, you just have to use the correct wording. Okay. On the left side, you would say the velocity on impact would be negative 14.14 meters per second. That's the left side. On the right side, you can say the velocity on impact when diving downward is 14.14 meters per second. So the word diving downward will take care of your negative. So go ahead and write your complete sentence, and that's a wrap.